Okay. Hello. What's up? Programming time. Up. So. Heute machen wir mal bei dem Ding hier weiter. Today we will continue to program this game controller. Last time I was working on the man, why am I tired? Last time I was working on the analog task. Let's see where we are with that. Is that the right one? Yes. So, where did we stop last time? Let's take a look. So, I wrote the software to read the analog values. And I also wrote a few functions to read the to convert the voltage, the raw ADC values to the voltages, and the CPU temperature to the ADC raw value to a CPU temperature. So with that, that done, let's take a look at the status of the system, if it works. A bit tired. Why is the target not responding? What is the problem here again? Target remote localhost, no message, no response. Okay. Try to connect again. Waiting for debugger connection. Waiting for debugger connection. And this time we have another error. Load failed. Try again. Target not responding. Great. And I need to select a different USB connector. Try again. Hey, TMK. Download in progress. Okay, this time it worked. And we have stopped at the initialization where we are supposed to stop, run through the code, and we land in the hard fault error. Why do we land in the hard fault error? Because I'm trying to receive data, come to a in, which is the NMI handler, and that is completely wrong. So for some reason, these things are not being set correctly. What? Okay, so what am I doing? I am grabbing this information here. So argument. Huh. For some reason, I'm grabbing the wrong information. Or I'm not grabbing any information at all. So let's start this again. What are you doing, TMK? Your day better than mine? I started my day today with worrying about tax documents, if I filled them out correctly. Because German tax law is stupid. Okay, so right here. So let's continue to the next breakpoint. Right now, the analog params has been reset. And now we should have all the data right there. Okay, so data has been transmitted correctly. From the calling function, from main into this thing. So I have the A in to com handle and the A out to com handle. Let's execute all the way here. XQ receive A in data 5. And we run into the hard fault error. Why do we do that? XQ receive. Huh? For some reason that thing suddenly resets. Okay. Well, that is very strange. Run again. So, analog params come to A in. Should be come to A in handle F5. We are in this thing. Q. Come to A in handle. Config assert. Task enter critical. EXQ still come to R in handle. And then during the memcopy operation, this thing crashes. So why do we crash at this point? Size. X item size. Whoa, okay. I think that's the issue. UX item size is some extremely large number. I think that is what is crashing this function. So then has to be an issue in the main file, main.c, where we create the queue. Yeah, maybe. So this crashes with the A out, right? No, come to A in. That's what crashes. Come to A in. Come to A in handle. Size of IO subsys are in. Upload again, and let's try to figure out where this program goes so horribly wrong. Okay, so we have analog params. This is in here. Come to A in and come to A in. Handle has been created here. Okay, come to A in attributes. Name. Okay, CB size, mem 0, all set to 0. Why is that all 0? Hmm. Okay, let's try to inspect this call here. So message size 22, message count 1. And that's the attributes where we store all this data. Okay. You see heap plus 8. Let's the address. Okay, so UX length 0, UX item size some monstrous value. Okay, let's see. At some point, we will see a memcopy function. And I want to know what this program, what this thing is transmitting to the memcopy. Okay, pxq, com a in handle. PC head. So, okay, so we have the buffer that is address. It's not really decoded. We start at UC heap +8, that is correct. Item size. Okay, item size is completely wrong here. And then, of course, we enter and immediately go into the hot folder handler because there is a memory overrun. Yeah. Buffer overflow, I don't know what this is called exactly, but we are way outside the limits. So for some reason, the size of the queue is not being calculated correctly. Okay. Somewhere in here in the creation function, there's a problem. A big problemo. How can I fix this? Okay, F5. Message count 1. Message size 22. Attributes. Okay, so the only thing that has been transmitted correctly is the message name, apparently. Take a look at the next one. Come to GPIO handle. Ah, look at this. This one was created correctly. Now if we take a look at... which one was this? This was... Come to GPIO. Come to GPIO.
Boah.
Wow.
Ja. Lass mal 2 Minuten.
Ja. Was denn?
Du hattest mir doch gestern aus.
Wenn du so Gas wegnimmst, dann hört sich das so an, als würdest du in so einer Tuning-Karre so das Gas wegnehmen. Und der Turbolader so zischt. Was war das denn gerade? Eine Uhr H1 weniger? Ja, warte. Das klick ich hier.
Sand.
So, wage mir jetzt dahin. Er ist jetzt wirklich rückwärts da reingestellt, das ist nicht schön, nicht schlecht. Ich stimme zu 14.
Dann mach auch. Chef 110. Zum Glück ist sie niedriger.
Ich bin eben schon unter seinem Flügel durchweggetaucht. Ich hoffe, das klippt mal einer hier.
Warst du nicht eben noch auf dem Acker?
Ja.
Das war ein
Uiuiui. Jetzt bin ich aber langsam geworden. Hoppla. Shit.
Angle of attack. Speed.
Sag, ist es dann eigentlich wirklich so,
Sync
oder soll
rate,
da was
sync
ändern,
rate,
weiß
sync
es
rate.
wer? Dass in der 16er nur 2 Harms mitzunehmen sind? Ist das wirklich so?
Tatsächlich.
Ey, hat geklappt.
Wirklich? Das ist ja mal richtig schade.
Ich hab einen Spike.
Den habe ich da gespiked.
Ach scheiße. Hä? Seit wann kann die SR11 verlocken, wenn man da eine Meile vor ist? Seit wann kann die einen abschießen?
War die Spike 16?
Ja, das bin ich. Wollte nur mal wissen,
Das
wer
war
da ist.
nie so. Haben die ein Update gemacht?
Wahrscheinlich haben sie das gemacht.
Dann hole ich mir jetzt weiter.
Also die Landung, die war gerade ein klein wenig sehr improvisiert. Aber es hat geklappt, ohne das Fahrwerk zu zacken.
Das siehst du auch, oder?
Ja.
Oh Gott.
Warning.
Ja, ist mit der Wasserstoff.
Someone stole the button here to get green. Frechheit.
Hallo.
Wir sind doch wieder hier.
Jo, so ein bisschen.
Ihr habt nur ein halbes Blitzplättchen, wo wir quatschen.
Is it going to hit? Is it going to hit? It looks at least very good. Yep. Boom.
Alright.
Wie läuft's?
Bisher haben wir recht gute Erfolgsquote mit der Raketen.
Schießt doch nichts zurück, wa?
The heck? What is doing this? What is this missile doing? Wow. Witz voll, ey. Das Ding war auf voller Lautstärke. Eine bessere Wärmeverteilung sorgen. Jetzt ein bisschen Olivenöl da rein tun. Gerade, obwohl. Ne, keine Chance durchstarten.
Ja, wir waren einfach zu schwer.
Shit.
Oh, das ist ein bisschen knapp, kann das sein?
Ich glaube auch.
Ja. Das war relativ knapp.
Wir waren einfach viel zu schwer.
Ich glaube auch.
Deswegen kann man einfach Nozzles auf 60 Grad stellen.
Bla,
Und
bla,
auf
bla.
30 Knoten noch entspannt landen.
Bla bla.
Es ist 12:30.
Yep.
Wo war by the way?
Achso, ja genau, frohe Weihnachten.
Delay plus minus Leute waren.
Mhm.
Mal in Discord reinschreiben. Ja, der Chris ist.
Firing, he's firing. Evade, evade, evade. So, wieder da. I'm back. Okay, so, so I still have this problem. For some reason... Alrighty, so the A intercom handle. Why can't I take a look at the handles? I want to see what is in there. I want to see what is stored in these parts. Memory. New. Paste. So I want to see this memory address. Okay, so yeah, okay, that's the address, but that doesn't say any, that is not saying anything. Okay, let's try to step over. Huh? Hard fault? Why? Didn't I just tell you to not execute this? Okay, so I called. Did we call the next function? What is wrong here? Why is this not working? So I'm creating the queues here. Maybe I have some wrong setup or something. Middleware free RTOS queues. Oops. So this is come to in and do dynamic allocation. What happens if I do a static allocation? Will that work? Let's set every queue buffer to be static. And try again. Hmm. Okay, so now this is all set. Attributes. Execute. Hard fault. Still the same place. Still getting... Huh. Come to A out now. The come to A in apparently worked. Let's verify this by setting a new breakpoint. Yep, okay. Receive works. But come to A out doesn't work. Probably because it is too big. So we have this. How big is the queue? So PXQ is not really set, right? Okay, so let's take a look. PXQ. To UX length. Well, this is set to 0. Well, maybe it's gonna be changed at some point. Task suspend all. Lock. Check for timeout. Okay. Where is this? PX new list item. Item value. Oh boy. Okay, so let's see. Free RTOS max queue size. Queue item size. Uh-huh. Hmm. I think I will need to use a different method to copy the sample array. Because if I remove this, I bet it will work. Let's take a look. Compile. Okay, it compiled. Let's try. No, it doesn't work. Okay, I get read from item size again, some crazy value. Okay, something is still wrong with the creation of the queue handles or the queue themselves. So we have the come to A out. Okay. In buffer, I also absence. In, out. Take a look at the RAM. RAM does. I don't think that the RAM is full, but let's try it anyway. I mean, it could be that I'm running out of memory. Let's increase memory size to 8,192. Maybe this will now work. If the memory size increased. No idea. I am apparently running out of memory and at some point. No, again. This thing wants from PXQ. What is this? Where is it overriding all this stuff? PRV, copy data from queue. Okay, so let's jump all the way to this point. So right now we are in XQ receive. Which one are we receiving? Come to A in handle. Here again, UX messages waiting, some ridiculous amount, message length, some ridiculous amount. Item size 0. Hä? And once we're done with this, data has probably been overridden. Then we run into the hard fault error, yeah. When we try to do stuff with the next queue. Okay, so PXQ has been wrong, has been created in the wrong way. Why? Why is the queue not create? Why is the queue wrong? Or created in this way? Am I missing something here? That's correct though. Okay, so A into COM control block. We take a look here. This is the A. This is COM to A out control block. And it's OS message QID, and this wants Q handle T. Okay, maybe there is a problem. Okay, so this thing XQ receive wants Q handle T, but I'm feeding it OS message QID. Okay. Q handle T. So, and this thing here gives back OS message QID. Let's take a look. What is Q handle T? Open declaration. XQ create. That's what. Maybe I need to. Oh, wait a second. So, this is how it's being created here. And I'm using XQ receive. Is there OSQ? Get. Message pointer. Okay, let's try it with OSQ. Message get analog params dot come to a in pointer in data message priority. Do we really care about message priority? We'll just set it to 0 and timeout is 5. Try that. No, let's type in there void. Or, okay, that doesn't work. Syntax error, can we just type in void like that? No, okay, so we have to set 0. OS message queue get STM32 OS message queue get OS message queue get. So it gets a message pointed to buffer or from message priority or null. Okay, let's set this to null. And we do not execute this. And also replace See if that works. Garuda, salve, Nabend. Hello. Trying to figure out why my software wasn't working here. With any luck, I have not managed to find the problem. Yeah, okay, because XQ message get means we just yeah, okay, so it can call this and then goes in here, has some ridiculous values, so this is PC read from item size completely wrong, and then it does some stupid stuff. Okay. Where is this going wrong so badly? Take another look here. Maybe there's something wrong the way I'm creating these things here. It's 24 bytes currently, because this is just holding a lot of pointers. So 4, 8, 12, 16, 20, 24 32-bit pointers. Okay. That is correct. This would be 52 bytes. Yeah. So it's either not being passed correctly or it's being created the wrong way. Wann ist das nächste Mal DCS geplant? Wahrscheinlich Freitag. Ach Mann, wieso funktioniert das nicht? Ein Schrott aber auch. Du hast Bock drauf? Sehr gut. Wir haben eine neue Kampagne gestern gestartet. Persian Gulf. War ganz lustig. Ist halt sehr anti-SAM-lastige Kampagne. Also sehr viel Luftabwehr, sehr viele Flieger von den Gegnern auch. Also man muss sich da, vor allen Dingen am Anfang brauchen wir ein bisschen was Cap und vor allen Dingen Seed. Aber sobald wir dann Kassab haben, müssten wir uns eigentlich, vor allen Dingen auch mit den Schiffen, die wir dann so als zusätzliche Verteidigung haben, müssten wir uns so langsam dann durchkämpfen können. Grüß dich, sehr gut. Also Freitag voraussichtlich wird der nächste Stream und Gameplay-Abend mit DCS. Die Woche jetzt hatte ich hauptsächlich erstmal mit Programmieren geplant als Content, weil ich muss das Ding hier mal fertig kriegen. Und ich hatte definitiv nicht erwartet, dass ich hier jetzt solche Probleme habe. Ich hatte gedacht, dass das einfach hier funktioniert, dass ich einfach nur einen Riesenhaufen Zeugs tippen muss und nicht, dass das Ding hier mir solche Probleme bereitet im Moment. So. Und jetzt im Moment hat er hier halt Message Queue Get. So, das heißt, der lädt sich da irgendwelchen Scheiß rein. Was ist denn, wenn ich den Speicher für die Tasks auch statisch generiere? Statisch. Static. Ich meine, es gibt natürlich noch die ganz andere Möglichkeit, dass ich sage, okay, scheiß auf die Queues. Das funktioniert aus irgendeinem Grund nicht. Ups, da habe ich gerade irgendwas, glaube ich, falsch geklickt. Müssen wir nochmal den Code-Generator aufrufen hier. Und noch was reingucken hier. Bei der Gelegenheit machen wir auch den Speicher größer. 8192 setzen wir auf 12.000 Bytes. So, speichern. Compile. Okay, also noch mal ein kleines bisschen. Also, warte mal, lass noch mal den RAM jetzt. Achso, ist. Okay, geht nicht größer als 8192. Gut. Heap still available, 8192 Bytes. Ja, stimmt, klar. Jetzt haben wir natürlich ordentlich Speicher verfügbar. Alles auspacken in statische Sachen, nichts dynamisch generieren. Wir können wahrscheinlich 4096 Bytes Heap nehmen. Vielleicht sogar weniger. Egal. So, probieren wir es aus. Save. Yes. Yes. Compile. Okay, eine Sache könnte natürlich noch sein, dass mir die Tasks nicht genug Speicher haben. Der Analog Task hat wie viel RAM? Stack Size. Tja, das könnte nicht genug sein. Aber gut, jetzt haben die Tasks alle ihren Speicher statisch zugewiesen bekommen. Execute. sind hier drinne. Analog params, analog control block, F5, 5. So, okay, HQ is come to our in handle. Okay, F5, 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 F5. Okay, so PXQ. Messages waiting. Ridiculous value. Item size 0, item length. Crazy value, and that means this thing is about to go crazy. Okay, so let's try one thing, and that is set for the analog task 1024 bytes stack size. That fixes it. That would be great. Compile. You're losing a lot of memory because now a full kilobyte is allocated to the analog task. Execute 5. And PXQ now shows those stupid values. Yeah, okay. Good. What functions do we have to use the queues? Maybe use XQ reset for the first time. Q reset. Okay, let's try this. XQ reset. Run once after I have transferred all the data into the pointers here. XQ reset button. So, what is this? This is a OS status T Q state equals OS message Q reset, and that's going to be analog params dot com to in. And come to A out. Okay. So we are resetting both. What? Oh, right. This needs to go away. And we want breakpoints right at that point. Compile. 8. Okay, so Q state 5. PXQ. Oh. Let's see what happens here. All right. Messages waiting has been reset. UX length, no reset. Item size, 0, wrong. ERX lock. Okay, 5. 5, 5, 5. So where are we at this point here? What is Q state? And wrong. Right, let's run again. So Q state is, what is that? Some crazy value. And it should be open OS status reserved 7 FFFFFF and hexadecimal something crazy. Huh? Okay, stat is OS okay. Ah, okay, because I wasn't in this function yet. Okay, so we get OS okay. And we run through this thing. And well, we get, even in this, at this point, we get the error. Okay, so there's definitely something wrong with the creation of the queues. That's the item length, the item size. Why? Why is there something wrong with the way the queues are being created? I mean, this timer to come attribute, where is this? Come to A in attributes. Wait, what is this? Create queues there. So come to R in handle. COS message queue ID. second. This is the... Isn't that the crazy number I'm seeing everywhere? Copy. Hex 2001 FAC. Hex 2001 FC4. That's the control block. Okay. Something is wrong with the way this thing is being created. Okay, setting all back to dynamic creation. We don't have enough memory right now, so let's increase the heap to 8,192 bytes. There's the problem. Come to a in task queue. Queue plus 76 bytes plus queue storage area plus stuff equals element size times number of elements plus 16. Here element size 4, and element size 4 is definitely wrong. The size of the given element type is unknown. Default size used 4. Q. Static. Huh. Okay, we cannot inform the code creation tool about the size of the queue. That's probably assuming completely the wrong values. Huh? Why is the analog task stack size only 128? Task and queue, analog, stack size 1024. Parameter. Okay. And we're out of memory. Schrottkrams. Okay, let's try 512. 512. Is this really... Is that really 5 times 4? 24 bytes? Or is it larger? It is larger, I think. Has to be. 1 byte. Ah, right, it's not full words. 1 plus 2 plus 2 plus Klammer auf 2 times 4 plus 2 times 4. It's 21 bytes. This thing. And I believe this is creating it as a 22 byte thing, isn't it? So size of, yeah, so this is 22 bytes. Okay. So HQ equals 0 or null. Then does some stuff. Let's get message queue ID has been created. Okay. Let's go in here. Oops, too many breakpoints. PX new queue. Okay, so in this case, it has been created maybe correctly. Which one are we creating here right now? This is the GPIO handle, which is 16. Well, for now it's in UINT 16T. And am I creating it here in the same way? Yeah, okay. So next up is, okay, let's restart. F8, F5. So, okay. So it's being created correctly. UX length, item size, all well and good. So we have name, attribute name, Q add to registry. Five. So XQ. Oh, why can't I see this? Okay, so try the following to make sure it's created the correct way. Every time I'm running, oh well, after I have created all the queues, I'm running this. XQ reset for all these things. Paste. Copy. Paste. I mean, it could also be that I'm doing something wrong with the way I am handling the pointers. I mean, it's entirely possible. Or I'm going to use a completely different approach, which then uses lots of mutexes and custom buffers. So px new queue. So this is the, which one is it? Oh, it's not being properly identified right now. Okay. We're at the first breakpoint. And run through it. Okay. And there's the error. So there is something wrong. Maybe the name I'm giving these queues is too long. Could that be? Queue registry size. Uh-huh. Queue registry size, max task name length. I am using rather long names, so 4, 5. Okay, let's go with 16. 16. Would be crazy if that was the issue. And execute. I'll be right back. Go somewhere. Eight. This problem. So where were we when this was called? Probably here. Is that? Okay, so Q stack is PXQ. Messages waiting, crazy number, and UX item size, crazy number. Okay. Okay, let's see. Maybe Chat GPT has a solution for this. My session has expired. That's bad. Log in with Microsoft account. After creating queues in with OS, was sollten wir hier? OS message new. I'm using STM32 cube IDE after creating queues and then executing OS message queue reset. The CPU jumped with the hard fault handler. The PXQ XQ struct in XQ reset shows values like in UX messages waiting, and UX item size. Indicate a incorrect value for the queue configuration and suggest a problem with memory allocation or initialization of the queue. Okay. Initial in the queues with this call. IO subsys. So, definitions for in and IO subsys are in IO subsys are in T is defined as follows. It looks like you're correctly initializing queue and providing the correct parameters for the number of message. Okay. It's important and aligned to a 4-byte boundary as required by the underlying RTOS implementation. If the issue persists, you may want to check the return value of OS message queue new to make sure it's not indicating an error. The thing is, return value of OS message queue new is the handle. Crap. Because this function here returns the handle, doesn't it? Or am I doing something completely wrong? Message create new. OS message queue ID type creates and initializes a message queue object. The function returns a message queue object identifier all null in case of an error. This function can be called after kernel initialization with the OS kernel initialize. It is possible to create message objects before kernel started with OS kernel start. The total amount. The message size is rounded up to double even number to ensure that the bit alignment of the memory blocks. Allocated from the message, have a fixed size defined with the parameter message size. Yeah. So we create the object. This creates the object. Message queue, thread ID, yes. Right, thread message queue1. Mid message queue. If equals null, error handler. Error handler. So what is wrong here? Syntax error? What? Why? F come to our in handle. Okay. Let's do it differently. X. Copy, paste. Oh man, so ein Schrott, ey. What is going on? Why is it not working? Execute. So. Yep. This is not null, so the message has been created correctly. Nope. Still crazy numbers. Interesting. Okay, these two numbers are the same. So let's try one little thing. Let's create these queues again, but instead of this value, into 16t. Try that. And then we're going to see if this works. Right, 16t. If we can reset the queues. Because if that works, then, well, it should not matter. Save. Yes, yes. What is wrong? I bet it's something very simple. Weiße Hintergrund macht ihr irre, Talk. Mich macht irre, dass das ganze Scheißteil nicht funktioniert. Ich frage mich hier die ganze Zeit, was mache ich hier falsch? Ich kreiere mir die Messages hier. Dann habe ich hier die Handles. Gehen wir hier rein. PXQ hat völlig verrückte Werte da drin. Warum? Was ist das für ein Scheiß? Wo war das? War das General? Appearance? Ja. Der da. Nee. Hä? Warte mal. Wo war denn das schönere Thema hier? Ich hatte doch eins runtergeladen. Egal. Was macht die Hand, der Arm? Wird langsam besser, aber immer noch ouchen. So, Handfold-Handler, nachdem wir hier in die Reset-Funktion reinrennen. Jo. Call that thing and... Wow. Och Mann, wieso läuft das nicht? OS message queue new returning a pointer. It's returning a non-null value. Wait. Is there something wrong with this function call? What is the maximum amount of... Oh, wait a second, I have an idea. What happens if I run the reset command, this reset function, directly after creating the queue? What happens then? What happens then? Aber dauert noch ein paar Wochen, bis das alles funktioniert, glaube ich. Also ich kann den Arm schon wieder besser bewegen. Ja? Also man merkt, kommt so langsam, aber so halt 1-2 Grad pro Woche. Das ist ein bisschen scheiße. So, PXQ. Komische Werte. Okay, also das ist definitiv was mit der Q-Erstellfunktion falsch. Also das wird falsch aufgerufen. Okay, so es gibt jetzt noch eine Möglichkeit, und zwar, dass das hier zu lang ist. CTA ist der neue Name für das Ding. Dass das aus irgendeinem Grund irgendwas überschreibt. Ansonsten habe ich keine Ahnung mehr, was hier noch diese Probleme auslösen könnte. I have no idea what could cause these problems. Talk, bei dir irgendwelche Ideen? Chat, habt ihr generell Ideen? Chat, do you have any idea what I might be doing wrong? Is the error staring you in the face? And I just don't see it. Oh, still. PXQ. So this has been cleared now. But the item size is still 2003 AC. Alrighty. Let's go back to where this queue has been created. So Why do you stop the music? Why is there a pause in the music? Was soll das? Frechheit. So. HQ equals 0. So Q has been reset. So message count is 1. Message size is 2. What? Message size 2? Nee. Come to A in hand. Ah, okay. Yeah. All right. Message size 2. Yeah, okay. It's correct. Yes. Okay, ist richtig. Execute. Okay. Message size 2. So. Have this. HQ still 0 or null. So we go into XQ create. XQ create. Q length 1. UX item size 2. Q type 0. UX item size. Okay. So Q item size in bytes. Okay, so px new q pp port m alloc size of q plus q size in bytes, and that is 80. Okay, px new q has been created and everything has been set to 0. So it's not 0, then PUQ POC storage equals px new q plus size of qt px new q statically allocated 0. Initialize new q. Okay. Set the head to the start of the queue storage area. Okay, so px new queue. PC head has been set. Heap 80 plus 88. Okay, so UXQ length 1. Item size. Correct. XQ generic reset. Okay, let's execute that. PC tail and PC write to been set. Then we set the queue type. And are we already? Okay, so now we exit this thing. VQ add to registry. XQ registry. Q item, timer mutex. It should have an update now. Yep, it has an update. The queue has been registered. And we return with HQ, which now is pointer to the queue structure. So, and now we enter OS message queue reset. This pxq and message waiting, item size, and queue number magically just became different numbers, and PC tail, PC write to, and all this stuff suddenly also has no values anymore. Was ist das denn für ein Scheiß? Tasks waiting to send, tasks waiting to receive. Wait, where are they created? They are created outside the message, yeah. Okay, what happens if I transfer a message onto the queue before I do stuff? No, it should not matter at all. Wait a second. Okay, so the message is being created. And message queue object, size of message queue object. No, so okay. And then OS message queue put. This is not using a pointer. Set breakpoints. Disable breakpoint. Disable breakpoint. And disable breakpoint. Execute. Ich stell's ja schon um. Mann! Mit STM32 Cube IDE ist es ja irgendwie immer so ein bisschen eigen, wenn man die Dark Themes verwendet. Da sieht man manche Sachen dann nicht so schön. Aber moinsen, oder eher gesagt, Nabend. So, wir wollen nicht restarten. Okay, also, das Ding ist erstellt. Aha. Ab in den Hardfault-Händler. Alles klar. Wir kommen der Sache näher. Okay, also das funktioniert. Und das funktioniert nicht. Blendet dich der Monitor nicht mehr so. Das ist gut. Okay, so, wir gehen hier rein. Und checken die Queue. Queue Handle T. Stimmt, ist nämlich keine Pointer. Hehehe, scheiße. Da lag das Problem. I am referring to these queues in the wrong way. So that means I have to call them differently in my analog task. Damn. Okay. Compile and upload. So how do we do this? So we can now run through this thing. Let's check this reset thing again. One more time to make sure it is doing what it's supposed to do. So PXQ has no crazy values anymore and has proper values. All right, so, and here we go. XQ message reset, yeah, because I'm using a pointer there. That is wrong. All right. So calling the function with this sign and then the address of operator. It is used to obtain the memory address of a variable. Okay. And we can access by referencing the pointer like this. Okay. I think I have done something wrong with pointers. Scheiße. Okay. OS message queue get. Declaration. I want to call the function s.st message queue get what referring to oops, referring to QID by using a pointer to a in handle which I'm transferring into the following, into the analog params struct, which is defined thus. How can I correctly call OS message queue get? Let's see if the AI can answer this question. Or if you are faster, chat. Are you gonna be faster than the AI? Uh-huh. All right, let's try that. See if that works. So, star, open the Klammer, close the Klammer, and yeah, okay. Paste. Let's try this. Let's try this suggestion from the AI. this works nice, finally. And it took me about 2 hours to find this out. Naja, wieder was gelernt. Zum Thema hier Schmutzfink. Pointer-Geraffel. Wow. Ey, keine Ahnung, wann ich das mit Pointern endlich mal richtig... wann ich das von Anfang an richtig mache, ey. Das ist doch nicht wahr. So ein Schrott, aber auch. Mann. Kacke. Ein Dreck, ey. Okay, copy. Jetzt können wir hier wieder schön anfangen. Die ganzen Dinger hier umzuschreiben, dass die Queues auch die richtigen Item Sizes haben. In. Come to GPIO. Come to Timers. Okay, die brauche ich nicht. In. Jo, da müssen wir was ändern dran. Set. Come to Layout. Und Timers. Okay. So we've come to in. We have come to GPIO. Communication to timers. In to communication. And out to communication. Communication to out. Okay. Let's have this thing create me some code. I hope there's enough room in the heap. Okay, execute. Let's see if this works. Oh, right, and now, damn it. Battery empty. Batterie leer. So ein Scheiß. Batterie alle. Power up. Und was läuft so bei euch, Chat? Ihr seid hoffentlich nicht am Programmieren / arbeiten, sondern könnt den Abend hier genießen. Und mir stattdessen zugucken, wie ich den Kram hier nicht so ganz hinkriege. DCS vor Yankee Alpha auf dem Kaukasus. Okay. Und räumt da was ab oder werdet ihr eher abgeräumt? Debugger Connect. And download and 8. Okay, so, das hin und her kopieren geht jetzt endlich. Gut, also, dann wissen wir jetzt schon mal, dass wir das so machen müssen. Denn diese Funktionen wollen keinen Pointer haben, die wollen einen Clear-Variable haben. So, Scheiße. Kacke. So was Blödes aber auch da. Wieso? Hä? Was? Oh, hat er die Verbindung verloren? Gibt's ja wohl nicht. Irgendwas ist ja irgendwie immer hier, ne? Irgendwie ist eines von den Kabeln nicht so ganz in Ordnung mehr, habe ich so den Eindruck. So. Okay, aber wir kriegen jetzt wenigstens Daten hin und her geschoben zwischen den Tasks. Close others. So. Open analog task.c. You have to do. Serve the layout system. Okay. For that, I need a little function. Serve the layout system. Yeah. Okay, for layout, because weil, deshalb und so weiter. Wo ist er? Keycard, Open Recent. Ihr versucht's. Wie war das noch, was Yoda mal gesagt hat? Tu es oder tu es nicht. Gibt kein Versuchen. Ups. Da wollen wir hin zum IO-Zeugs. Also. PWM Out ist der hier. Und das ist Timer PA11. Das ist dann welcher Timer? Also auf jeden Fall brauchen wir erstmal Timer, Handle, Type Def, Pointer, Handle, Q. Und wir müssen das Ding öffnen. RTOS. Ne, Korrektur. Wir brauchen PA11, Pin 32, PA11, Timer 1, Channel 4. Das ist minimal unpraktisch. Dass das beides derselbe Timer ist. Scheiße. Nee, Mist. KG. Ach, wie scheiße ist das denn? So, PWM-Generierung auf Kanal 1, Timer 3. Ach, guck mal hier, da hätte ich PA6 hätte ich noch frei gehabt. Schrott. Dreck, verdammter. Och, Menü. Hardware Design Flaw. Können wir gleich mit reinschreiben hier. Changes von Revision B zu C. IO. PWM out moved from PA11 to PA6. Now uses timer 3, PWM3, channel 4, no, channel 1 instead of TM1, channel 4. Wir können es ja eigentlich doppelt belegen, ne? Beide Pins anschließen. der hier dann High Impedance ist, ist das egal. Machen wir folgendermaßen. Copy, Paste. Okay, so move everything. Oh, new feature oder was? Ah, nice. Update PCB. Annotate. Close. All right. Yep. Let's place this thing. Yep. Let's place it here. Like that. All right. Let's remove this or not. What is the thickness? Thickness is 0.2 millimeters. Use 0.2. We want the bottom side of the board. And we come up to the top layer, connect. Great, delete. And then remove. Yeah, okay, so, and wait, where can we go to the bottom side? Via use minimal, via footprint. Okay, we have to go under the board, right? Under the processor, I think. Or can we go down here? Nope, that's not possible. So come on. Was da hin? Du Scheiß Trace. Kann doch nicht wahr sein. Alrighty, how do we get from here with a PWM signal over there to the place where we want to go? Oh boy, this is gonna be crazy. No, not next to the RNA signal. Oh no, oh Mann, ein Scheiß, ey. Okay, wait a second, we can... Okay, we can go to minimal trace thickness. Oh, cannot. So this is length matched. Do I have any other pins available? PC15 maybe? No. PA2? That would be timer 2. What am I using timer 2 for? For counting stuff. Okay, timer 2 is reserved. Timer... The only timer I have is timer 3. Scheiße. Okay, so that means bottom layer. I need to cross GPIO 1 and 2. And I see the place where I can do that. And that place is right here. So, and then I have to sneak around here somewhere. Why am I not pushing other traces away? I probably have not. Okay, so what root set layer pair? Oh, cool. New features in KeyCard. Nice. Okay, so interactive routing settings. Shove mode. Optimize entire track being dragged. Yes. All right. Yeah, the GPIO lines can be much closer together. Let's change this distance here. Then I have a bit of room. Yep, that ground via can be pushed a tiny bit. Go up here. Jump layer next to the ground via. Jump layer again. We can push aux count a little bit. Come up to the top layer and connect. So now I'm checking 0.147 millimeters thickness for 50 ohm trace. Am I concerned with 50 ohm impedance? No. Not in this case. Okay, time to add a few more ground vias then. The ground via, that's a 3.3 volt via. Okay, B. Yeah, okay, so this is the 3. Wait a second, what's this? This is a 3.3 volt plane. Yeah, okay. This is all right. This is okay. Thing is, I just cut this layer in half right here, which is a bit of a problem. Thinking the inner layer here is solid ground plane. Yeah, okay. So 3.3 volt vias here are actually stupid. Unless I bridge them a little bit like that. But this via is not good there. Okay, so okay. R74 allows R74 allows connection of PWM out to PA11. So, and with that, I have this thing is compatible to all the software. Just like I did here, I did this here with PA12 and PA15, which are both aux count. So PA12, GPIO external interrupt, and PA15 timer 2 external trigger. Question is, could I use external trigger on timer 1? PA12 ETR. Heh. Yeah, that's the issue. Trigger source. Yeah. Trigger source conflict with RCC master clock output. Really? Why? Where's the output? Isn't that on? Okay, so PA11 timer channel 1. That would be timer 1 ETR. Yeah, okay, that's so ETI external clock. Good. Maybe I can use these timers afterward, but no, I don't know. Egal. Timer 3, channel 1, and channel 1, PWM, channel 1. Question is, do I want to do tiny soldering job, or just for the time being just copy use the, I think I will just use timer 1 channel 4. Yeah, timer 1 channel 4 will be used for now. And in later revisions, I can still switch over to timer 3, channel 1. Okay. PC 15. Going to use this as an input. GPIO. PC 15. 15. Input mode. Pull up resistor. And I'm going to call this revision C. No, revision B. Mark. Revision B select. So if this is true, this is revision B. And if it is false, it is revision C or higher. Ref C and ref B select. Okay, and ref B select is connected to ground through a resistor of 1 kilo ohm. Or 100 ohm, 47 ohms, 47. Yeah, 47 because I have that. Or 120. Let's go with 120. So revision B select. 120 ohms to ground. Oh. IO. Added base select signal. If high during startup, board is a revision B board. If low, board is higher, revision. Okay, R75. Ach du Scheiße, das ist eine schlechte Position. Wo passt der jetzt hin? Ja, dann muss der hier hin. Geht ja nicht anders. Na, passt ja doch tatsächlich sogar halbwegs gut rein hier. Jo. Also wenn der High ist, haben wir ein Revision B Board. Wenn der Low ist, haben wir ein Revision C oder höher Board. Ach, guck mal, ich habe noch 2 Pins frei. So, dann generieren wir den Code. I'm always doing something confusing. Hey, Aki. What's up? Oh, I just figured out it might have been a better idea to place a few signals on different pins on this processor here. So I have to
Surprise, motherfucker!
have to write some code to handle this. So we want a uint 8t pointer, no, not pointer. This is gonna be just a variable revision b indicator for revision b board. High equals rev b, low equals higher revision. Those look like fuses to you. No, they are resistors. American public school system. What did you learn, by the way? Or are you still learning, or are you through with school stuff? And there's this trope that you never stop learning, of course. But what did you study, if you studied anything? So. We have timer 1, copy. Okay, we have analog params, but timer handle equals reference to TM1. Analog params, but have B equals 1 equals GPIO read pin. What did you studied medicine? What? You studied medicine and finance and investments. What the hell? What didn't you study? B select GPIO port and ref B select pin. If X pin what can we get from this function? From this function we get a GPIO pin state. Plus 2u into 8t. No, we could do this. Well, it's 1. So if this equals set, then do that. Else do this. And taxes, yeah. Yeah, I had a not so nice encounter with tax stuff. Yes, last night. I had to fill out some, I told you I had to fill out some forms and TM1 undeclared, HTM. You feel like you're doing an exam, but an exam that could cost you a lot of money if you fail or if you do anything wrong on it. What? Open declaration, pin state, GPIO pin set or reset. Okay. GPIO pin set. So if the pin is high, then we have a revision B board, and then we have to handle revision. Yeah, we have to access timer 1 channel. What was that? Damn, I forgot. Timer 1 channel 4. Otherwise, we will have timer 3 channel 1. Maybe if you watch it long enough, you will learn. Maybe that could be. Once I have this project done, I will probably do a something more simple, where I start from the beginning and then build up from that. But this project here, my game controller for university, for my master's project, that's pretty advanced stuff. I think we're using the free RTOS pointers left and right to handle, to transfer data and stuff. Was baue ich denn da? What I am building, this is the board. This is the game controller. And here, up here you can connect, or students can connect their circuits, and then a computer game can use this processor here, either via serial or Bluetooth, to talk to this board. Hope you get a high score. Yeah, I hope so too. So okay. Next step, serve the A-out system. Okay, for that we need some functions to call the PWM outputs. Void set A-out 160 millivolts, 16-bit value that describes the millivolts, and now we have to calculate define A-out ref 3300 roughly, and also define A-out steps, and by the way, what really helps when you are programming is ChatGPT. So if you want to program stuff and you have questions, like what is the resolution of the PWM output of timer 1 channel 4 on a STM32 F103 Okay, so we have to set the prescalers and clock frequencies of the timer. So, parameter settings. So we want okay, so counter mode up, counter period, no division, repetition counter off. Channel 4, pulse 60-bit, no. Fast mode, what does fast mode do? Output compare. What are PWM mode 1 and 2? By the way, I think I just discovered another hardware flaw. Can I set the frequency individually for each channel or only for the entire timer? Set for the entire timer, not for individual channels. Damn. Trap. That's another hardware flaw. Right there. Yeah. So that means PWM signals will have to be... Yeah. I have to... Yeah, I have to put in a lockout. So that either I have PWM output or PWM signals, so pulse width modulated output signals on PWM 1 or 2, which go directly to the outputs here. Or I can serve the analog output, but not both. Otherwise, I have to use a fixed frequency. Or I am defining the PWM A out I could use that. I could do this. So fixed, well, not fixed frequency, but I'd brief that the A out value or A out A to the specified millivolt value. The maximum output is 3300 millivolts with a resolution of let's say 1024 steps. 3300 divided by 1024, that's 3 millivolts. Okay, so that means let's see if ChatGPT can write me a function that takes into account the different frequencies. Yes. So what counter period do I have to set if I want the PWM
frequency to be PWM frequency to be, let's say, 500 kilohertz or 1 megahertz. What's the clock frequency of the processor? 48 megahertz. So timer clock frequency, timer period 271. So let's take a look. Timer clocks are at 48 megahertz. So good. To be 1 megahertz at a clock resolution will be 1024 steps, and the system clock is 48 megahertz. Let's see what ChatGPT says and if that makes sense. Duty cycle resolution shall be 1024 steps. So let's try again. And while ChatGPT is generating a response, let's set up the prescaler. 16-bit value must be between 0 and 65,500 and something. Counter period needs to be set to 1024. Nice. Calculates everything. Prescaler value 46,875. 46,875. Counter period 1024. Internal clock, no division. And we have a network error. Since the prescaler 46 point, oops. So 47. The danger with ChatGPT, on the other hand, is you rely on it too much. You just take its answers just like they are, and then yeah, sometimes I had it once. Sometimes it tells you some bullshit, and then suddenly, yeah. Then you have a problem. So I don't have any DMA available. No, I don't have any DMA, at least not active. I could bring a DMA in here, but I don't want to. So we want 1024 steps.
Prescale is 47, so we have just about 1 megahertz. What is 48 divided by 3.3? 15. 48 divided by 15. 3.2 megahertz. So 3.4 something. So divide by 14 and set the counter period to 3,300. This it would run at 3,000. Okay, wait a second. What is the PWM frequency with the following settings? This clock 48 megahertz. Prescaler 14. Counter period 3,300. Save and submit. By the way, Aki, are you streaming today? Because it is getting late and I think I will end soon. That would be a little bit low. $48, 111,111 divided by 3,300. 14.5 kilohertz. That's a bit low. Let's get a 1. I have calculated 0.456 megahertz, so 46 kilohertz. Is that correct? 14 kilohertz, yeah. That is a little bit low. Yeah, 0. Okay. So please get a 0. Please get a 1. Can we boost the... Second, I am MCO output. That is this pin. Timer 1, channel 1. If I send out a signal there, was soll das? Wo ist meine Musik hin? Frechheit. So rude. So rude of YouTube to always disable the music after a certain amount of time. Okay, so I want higher clocks for the timer. But I have to achieve a 24 megahertz clock signal on the on pin PA8. So right now I'm sending the signal from the now sending the clock signal that is driving the entire system. Hey, Grazi. Right now I'm sending the clock signal for the entire system through this ×2 divider ×2 to this divider to the output. Could also use 48 megahertz. What if I send that signal out? Bist schon die ganze Zeit am Blocken hier. Nice. Paar Viewer hier. Sehr gut. So what if I send this signal out? Oops. But through the timer. Okay. Let's ask ChatGPT. Calculate the period, the counter period for a PWM frequency of 24 megahertz. Oh boy, that's gonna be crazy. Can I... Okay, now this is gonna be interesting. So I want a signal with a frequency of 24 megahertz out of a... So 24 times, I don't know, 3 would be 72. Ja. Na, ganz ehrlich, die SD-Karte brauchst du nicht. Die Biester haben so viel Speicher. Also, meins hier hat, warte mal, jetzt habe ich hier drin. Ich glaube, 256 Megabyte sind hier drin. Warte mal. Ja, 256 Max drin. Das brauchst du gar nicht. Warte mal. Die sind 128 oder sogar 256 Gigabyte zu wenig? Also, ich habe hier 256 Gigs drin und es reicht locker für alles. Wie voll ist denn das Ding? Und ich mache einiges an Bildern in letzter Zeit. Occupied 75.9 gigabytes. Das ist ja gar nichts. Ja, nur wieder. Das ist unnötig. So if we generate this here, this signal. Can I generate a pulse? That would be interesting. So can I generate a pulse? What is fast mode? What are PWM mode 1 and what differentiates PWM mode 1 and 2? Dass die Handys mehr kosten, weniger bieten. Also das bieten tun die mehr. OLED-Display und all solche Geschichten. Output is high when the counter value is less than the pulse width value. Compare register. Okay, and the other way around. Okay. So this is the pulse register. If that is counter period divided by 2, then we have the signal at half clock frequency. No, not at half PWM frequency. Yeah, 50% duty cycle. So timer runs at 48 max. Can we go 72? Question is, how high can I go here? We can go to 48. And how high can this chip be clocked? 89833. Let's see. 89833. Let's see how high I can clock that chip. Maximum clock speed. Damn, 25 megahertz. Hit. Die neuen Samsung, wie, die haben weniger Auflösung. Was? Okay, dann ist echt fail. Alrighty, so I need a secondary PLL in here. Damn. Or I could use the HSI clock here. Bump this up to 72 megahertz. Can we go 50? Let's see. Yes. Okay, 52 megahertz. 52 megahertz would mean that we overclock this chip by about 1 megahertz. Shall we try this? Try a little bit of overclocking. And the alternative would be underclocking. I'd rather overclock. I should have used a 16 megahertz crystal. That would have been better. Yeah, should have used 16 meg crystal here. Schön scheiß. Then I would at least have 16 megahertz output. Well, if this chip cannot handle 50, yeah, about a megahertz of overclock, then I have to downclock it to 8 megahertz. So the maximum output frequency would be 3.5 megahertz. That's not great. I'd rather have 12 megahertz maximum output frequency. All about, we are going to see how high we can. That's something for tomorrow. Oh, not tomorrow, for Wednesday. Trying to figure out how high we can clock this one of these chips here. So I want a frequency of 500 kilohertz. So I need to be able to count up to 500. 500 to the value 500 times per second. So 52 million divided by 500. Oops, 500,000. That's a count of 104. That is a bit low. I would get a PWM frequency of 203 kilohertz with 256 step counter period, or 512. I would get 100 kilohertz. So let's calculate 100,000. So that's 520 steps. And now we calculate 3,300 divided by 520. And that is 6.3461 millivolts. 6.34. At param millivolt output voltage of the output. And 16T, and we need the param HTM pointer to the Timer Handle. Heute nicht zocken? Nee. Heute ist gleich Bett gehen. Weil ist 0:17 Uhr. Zocken ist morgen, Stellaris-Runde, aber halt kein Stream. Und nächste Zockrunde wird Freitagabend sein. Ich will halt dieses Game Controller Projekt jetzt mal voranbringen. Da muss ich mal jetzt einen Schlag reinhauen, weil ja, das dauert schon viel zu lange eigentlich. Ich habe da in letzter Zeit ein bisschen wenig getan. I did not enough for this Projekt. GEM, handle, type def, HTM, pointer HTM. Count equals HTM dot channel dot channel 4 dot or wait, how can we access this? Nope, not like that. HTM dot instance dot count register. Grab the counter period from the timer peripheral. And now we calculate based on the counter period. So counter period is at least, lowest counter period would be 520. Let's see if I can update the counter period on the fly. Can I update the counter period at any time, or do I have to initialize the timer again? And then we have the count. That would be the steps. Load step size equals cost to float how did I call this? That was a out ref. Oh, we don't need that. Just a out ref divided by cost to float count. Du gehst auch mal Richtung Bett. Alles klar, warte mal noch, bis wir hier raiden. Grasi. So viel Zeit muss sein. So, step size is a out ref divided by count. So, and that is 3,300 divided by 520. That would be 6.3. So if we increase the frequency by double, 3300 divided by 1040. Oops. 1400. Correction. 1040. Then we have to change the step size. To do, take changing count values into account when calculating the pulse register value. To do update pulse register value for channel 4. Okay, compile. And yes, okay. So, and with that, let's end today's stream. I will be back on Wednesday. And before we end, let's raid someone. Aki, are you online? No, you aren't. All right, then we are going to raid the Dynamite Twins / raid Dynamite Twins. They are content creators, streamers based in New York. Yesterday they were playing, was it yesterday or the day before? Anyway, last time I saw them, they were playing, they were running around in New York searching for Pokemon. It's already dark in New York. Interesting. I thought... Huh. Alright. Okay, let's head over there. I say thanks for watching. And have a good night. And have fun with the Dynamite Twins. Good night.